This lesson is all about properties of addition. These are rules that tell us what's okay to do and how math works when we're adding things together. These have something in common with the properties of equality in that they look pretty simple, but later on when we start putting lots of them together at once, they can get a little bit more confusing. And it's helpful to us if you can remember these basic properties that we're starting with. The first property we're going to look at is the commutative property. This property says when you're adding numbers together, the order that you add them in doesn't matter. You know this property intuitively because you know that when you add together 3 plus 2 and 2 plus 3, you get the same answer. When we're adding, because this is a property of addition, the order doesn't matter. In general, we'll represent this property instead of using specific numbers like 3 and 2, with variables that could stand for any number. A plus B is the same thing as B plus A. A and B can be positive numbers, negative numbers, whole numbers, rational numbers, irrational numbers, real numbers, imaginary numbers. They can be pretty much anything. The operation of addition doesn't care what order those two things get added together in. A trick to help you remember the name of this property. If you look at that word commutative, think about commuting. Commuting is when people go back and forth to work or back and forth to school. And the distance is the same no matter which direction they're going. When you're commuting to school in the morning, if you commute back home in the afternoon on the same route, the total distance is the same no matter which direction you're going. This is the commutative property of addition. Next is the associative property. When you're adding 3 or more numbers together, it doesn't matter which two you add together first. In the examples below, I'm going to use parentheses to show you which ones I add together first. So here's an example with some numbers, 3 plus 2 plus 5. There's a number of different ways that I could do this. I could add the 3 and the 2 together first. 3 plus 2 is 5, plus 5 more would give me 10. I could add the 2 and the 5 together first. 2 plus 5 is 7, plus 3 more is still 10. Which two numbers I add together first doesn't change the sum. Now notice here that this is all an addition problem. There's no subtraction or multiplication or anything else in there. This is the associative property of addition. To help you remember the name associative property, think about associating with people. Associating with people means like who you hang out with, right? An association is a group of people that sort of tend to clump together. The associative property says it doesn't matter which numbers you clump together first when you're adding them. The identity property of addition. Identity means it stays the same. It keeps its own identity. This property says when you add 0 to a number, you don't change that number's value. You know this intuitively. 5 plus 0 equals 5. In general terms, we'll say that any number, a plus 0, is still equal to that same number you started with, a. Adding 0 doesn't change a number. The inverse property says when you add a number and its opposite, that means a number that has the same number part but a different sign. One of them is going to be positive, one of them is going to be negative. When you add those together, what you get is 0. Again, a number and its opposite just means the positive and negative versions of that same number. So an example here would be 3 plus the opposite of 3, that's negative 3. When you add those two together, you get 0. This also works if the number you start with is negative, like negative 3.45, and then you add the opposite of that, which is positive 3.45. When you add those two together, they have the same number part, but one's positive and one's negative. You get 0. In general, when you add a number a and its opposite, the opposite of a, shown here as negative a, you get 0. Again, a reasonable question to ask is, why bother learning these things? Well, remember before, in our properties of equality lesson, we looked at solving a two-step equation. What I want you to do is to try and solve this two-step equation, 2x plus negative 3 equals 9. Pause the presentation for a minute while you work through in your notes how to solve it, any way you can think of. Remember, you're trying to find out what number you have to plug in for x to make this equation be true. Please do make sure that you show your work in your notes, because we're going to need to label some parts of your work. Once you've done your best to solve this equation, you can resume the presentation. Okay, so let's see what we've got here. 2x plus negative 3 equals 9. That's the equation that you were trying to solve. These properties that we've been working with are what let us solve these equations. So for example, the first thing you might do in this equation is you might add 3 to both sides. What lets you do that? Why is it okay to add 3 to both sides of the equation? Why does that not sort of mess things up? Well, the addition property of equality, we learned about that in our last lesson, says that if two things are equal to each other, you can add the same number to both sides, and the results are still equal to each other. Next, we took the negative 3 and the positive 3 we just added, and those two together add up to 0. So now our equation looks like this. 2x plus 0 equals 9 plus 3. How do we know that negative 3 and positive 3 add up to 0? That's the inverse property of addition. When we add a number and its opposite together, we get 0. Next, we took the left-hand side of this equation, 2x plus 0, and we said, well, really, that's just the same thing as 2x. So we have 2x equals 9 plus 3. How do we know that 2x plus 0 is the same thing as 2x? That's the identity property of addition. Now, you may not have even written that little step out in your work where you showed the plus 0 part, but it's important to notice that that is actually part of the work that you did. You might not show every last painful step in the process, but these steps are there in the work you did. We know that 9 plus 3 is equal to 12. And we also know that 2x is equal to 9 plus 3. Well, if 2x and 12 are both equal to that quantity 9 plus 3, then 2x and 12 must be equal to each other. That's the transitive property of equality. If two things are equal to the same third quantity, then they're equal to each other. So 2x must be equal to 12. You would probably do one more step then to divide both sides of this by 2 to get x equals 6. See, all of these properties, we've been using them for a number of years, and we just haven't given them names. Now I'd like you to try. The work below is the steps that are needed to solve an equation. What I'd like you to do is to pause this presentation, copy down this work, and see if you can identify, actually write it in your notes, which property goes with which step of this equation. If you need to look back in your notes to see which properties are which, that's fine. That's a good use of your notes. A reasonable question you might be wondering is, do we need to know the exact names of each property? Because maybe floating around in your head trying to keep the identity property separate from the inverse property gets a little hard. Here's what I'll tell you about that. The most important thing is that you understand what each property lets you do. So for example, if you say to me, well, it's that property that says that if two things are equal, you can add the same thing to both sides and what you get will still be equal. That's the really important part, is understanding what each property lets you do. Right now, you're not required to memorize the names of the properties, but it's going to make your life a lot easier the sooner you in fact learn them. So as you're going along, focus first on what the properties do, and second on their names. There will come a time in your math education when you need to know the names and you need to be able to rattle them off quickly, and you may as well get started on that now. All right, next we're going to look at properties of subtraction. Everything else we've done so far in this lesson is properties of addition. Properties of subtraction. First, I want you to look back in your notes to see what the commutative property of addition says. Pause this presentation for a minute while you go back and look. Okay, so now you've seen what the commutative property of addition says. I want to ask you a question. Do you think that subtraction is commutative? In other words, do you think that there is a commutative property of subtraction? I want you to explain, again in writing, right there in the middle of your notes, whether you think there's a commutative property of subtraction. And I want you to use an example problem to help show me what you're thinking. So you're going to both write out what you're thinking about this and do a math problem. You're going to make up your own math problem to do right there to help show me what you mean by the written words. So pause this presentation while you do that. Okay, there is something called a property of subtraction, and here's the way it works. It says that subtracting a number is the same as adding its opposite. And again, this is a property that you've used a bunch before, but maybe you didn't know this was what you were using. So here's an example of this property of subtraction. 5 minus 3 is the same thing as 5 plus negative 3. So probably there were a bunch of times last year where you took an expression like 5 minus 3 and you rewrote it as plus negative 3. That's this property of subtraction that you're using. Why the heck is this helpful? Well, if you look at this, what you really did was you rewrote a subtraction problem as an addition problem. These two problems, 5 minus 3 and 5 plus negative 3, they're equal to each other. They have the same value. The way we rewrote it didn't change the value. But now we've got an addition problem, and all of those properties of addition apply. So we can use the commutative property and the associative property. We can use all of those properties on the problem on the right, 5 plus negative 3, when we can't use them on the problem on the left. Because subtraction is not commutative and it's not associative. But addition is commutative. We can do addition problems in any order. So this ability to turn a subtraction problem into an addition problem is a really useful one to have. In general, the way we write this property is any number a minus some other number b is the same thing as that number a plus the opposite of b. I don't say that as negative b because that little negative sign in front means we're going to switch the sign on b. If it were positive, we're going to make it negative. If it's negative, we're going to make it positive. So again, the properties of addition, like commutative and associative, they don't all work for subtraction, but you can turn subtraction problems into addition problems. Then all of those addition properties do work. Here's an example. 2 minus 3 plus 4 minus 5 plus 6. This is a fairly simple arithmetic problem, and you could go ahead through and do this problem in order, sort of working left to right. But an easier thing perhaps to do is, because I can't use the commutative property on the subtraction problem, I can't change the order of any of this around. I have to do it in order from left to right. But here's what I can do. I can rewrite it as an addition problem. 2 plus negative 3 plus 4 plus negative 5 plus 6. Now, I can use the commutative and the associative properties on this new problem because it's an addition problem, and the properties of addition work. I find it helpful to group all the positive numbers together first, 2 plus 4 plus 6, and then the negative ones after that, plus negative 5 plus negative 3. The commutative property says I can add these things together, I can change the order, and the associative property says it doesn't matter which ones I do first. So 2 plus 4 plus 6 Well, let's see, that's 6 plus 6, that's 12. And negative 5 plus negative 3, that's negative 8. So I get 12 plus negative 8. And then the property of subtraction says that 12 plus negative 8 is the same thing as 12 minus 8. 12 minus 8 is just 4. So by rewriting the subtraction problems as addition problems, I can make use of some grouping and rearranging that makes the problem a little easier to do.